Okej, som sagt, jag heter MorganRody och jag ska presentera SIMS. Jag kommer köra på engelska. Sustainable Intelligent Mining Systems. So in the previous presentation there was quite a number of questions you had, how we do this and this. This will give you a lot of solutions. First, before we get into SIMS, where does it come from? SIMS has been given European funding from a program called Horizon 2020. And it's a program that runs for about 7 years. They've had 80 billion euros in funding. And just last October, they said they had about 30 billion euros left in funding available for European projects. So if you are interested in this kind of thing, this is a great place to start. And Epiroc is always looking for partners in these kinds of projects, so please come talk to us. The SIMS project. It's a 3-year-long project, a budget of about 170 million crowns. It started pretty much exactly a year ago. So the first year was mostly planning. We are now in the second year, and we're starting to get some demonstrations, and that will continue into the third year. The next slide is just a quick small film intro into the actual project. Yeah, so there you have SIMS, quick intro. So who's part of this group? Let's see, we got a laser pointer. At the top here, we have the European Commission who gives us our funding. Epiroc is the coordinator and project manager. And then on the next row, we have all of our demonstration mining companies that are located throughout Europe. There's Finland, Sweden, Poland, Germany, and Sweden. Then the next row is all the equipment suppliers. And then finally we have 2 very top-class universities in Sweden and Germany. And if we have a look at the mine cube, this sums up in a good single picture the whole project. Starting at the top, we're going to use 5G. Underground communication. We'll be replacing Wi-Fi. Wi-Fi has its place. It has worked in some instances, but we see that 5G is definitely the future. You also notice in this cube that this project represents almost the entire cycle of a usual drilling and blasting typical type of mine. At the top we have, At the top we have material detection, so where we can send down drones and look at a face and identify what material this is. In this case, we're looking at salt at a mine in Germany. And that was mentioned, I think, this morning as well, how we can be more effective. Why should you mine the entire face when you can do just half of that? We also have drilling, and this is something that we're going to do with battery machines. We have blasting and drone inspection, more battery machines, loaders, trucks, bolting, roof bolting. We'll have a virtual mine that you can actually walk into a real mine and have a look and see what demonstrations we're doing in SIMS. We also have electric management. This is going to be a big thing for mines in the future if they go over to all electric vehicles and things like this. And maintenance reporting from all our machines. So here are the locations throughout Europe. As mentioned before, we have Agnico Eagle in Finland, KGHM in Poland, Germany, K+S, and Boliden and LKAB are the other mines. And Luleå, there's no mine here, but we will have a big demonstration at LTU, not too far away from here, of the virtual mine. So after drilling and blasting, we often have to wait many hours to go down and send somebody down for inspection to make sure that the area is okay to send down people. Why wait when you can send a drone after after an hour or so? We also, extraction, I talked about that earlier. Battery-powered tramming, drill rigs. So this is a big thing, electrification. Our goal at Epiroc and in Sims is to provide machines that can work the same as they were before with diesel engines. And in this case, we're removing the diesel engine, replacing it with a battery pack, and the machine will be tramming. When a drill is in place and drilling, then it's connected to the mine's electrical network. The charging machine, this is done by hand today. ABB is going to robotize this. So a semi-autonomous platform will go down and we'll be able to load and prepare a face for charging explosives. Production blasting. So over at KGHM, at their mine in Poland, there are a lot of earthquakes, small earthquakes, but there's a lot, hundreds per year, and this is a problem, especially when you have so much stress in the surrounding rock areas. So they've come up with a method how to optimize production blasting, and this is quite interesting as it's proven that it can actually reduce the stress in the surrounding rock if it's done and timed in a certain way. And this is all these tasks are safety related. Bolting, this is generally a bottleneck in the mining process. And this test is actually happening right now at LKAB, I'm happy to say. The field test is happening today and is going to continue for a few more weeks, months. And here we aim to increase the efficiency of how many bolts you can put per hour or per shift. I mentioned KGHM. It's a big mine in Poland. Anybody care to guess how many bolts they put in their roof per year? Just throw out a number. 5 per year, okay. We start really low. It's about 3 million is what they're putting in the roof. And if you can improve that by 20, 40%, that's a huge improvement in bolting technique. Roof crack detection. After blasting, there's always some sort of rock that's ready to fall on somebody or a machine. We need to be able to find those in a safe way instead of sending somebody down. Here we can put a camera on a drone, and Aachen will use long-wave infrared to identify these areas, and then we can send down a scaler to remove them. Communication and positioning. This is very important, communication and positioning. A lot of mines spend hours per day, hours per month, per week, looking for things that they have lost. Anybody that works in a mine knows that, but Joe put the drill rig over there. It's supposed to be there. Or this tool that I need is another location, and it's not. Then you have to send people down searching for hours to find these things. Mobile hours is a way to position pretty much everything that's down in the mine, and that's the goal, to know where everything is instantly. Not just because it's easier to find things, but from a safety point of view, right? If you have to evacuate a mine for whatever reason, you need to know that all the people are leaving as well. And how do we ensure good communication? I mentioned earlier 5G. This is the way forward, not just above ground, but below ground as well. And this is going to increase our ability to have multiple fleets of multiple types of machines underground working together. Semi-autonomous battery vehicles, again, electrification. We have a loader and a truck in Sims that is being built also right now in Örebro. Very cool. They will be ready 1st October this year and will be delivered to our test mine in Kvarntorp, just outside of Örebro. And one of these machines will be semi-autonomous, and it will have a feature called driver assist, which basically prevents a driver from driving into a wall. Anybody that's delivered mining machines or worked with them sees that after a week, the whole side of the machine, there's no more yellow paint left, it's all gone. Because these drivers, their goal is to get out as many tons as possible. They're not too concerned about the machine. But if we have this kind of feature on the machine, they can probably drive faster, much safer, and have much lower maintenance on these machines. And you might even have some yellow paint after a year left on the side. And of course, these diesel-free loaders and trucks will do as much work as their diesel counterparts. 1 minute, Jenny, already. Process control, dispatch fleet management system will integrate our machines from Epiroc into ABB's 800XA process control system. Mentioned the virtual mine, then we have a digital twin, which will be a simulated mine, where you can input all the different processes that are happening and find errors or issues before they happen. Attractive workplaces. This is also was a topic this morning, and this is such a great work package to have in a big project like this. LTU is heading up this one, and they're asking a lot of really good questions, not just from different interviews of different workers, but at the mines as well. And another thing is, why is mining important? This is another aspect of Sims. We have to be able to say, why is it important? Why do we need mining? I think that everybody in this room knows that without mining, you wouldn't have a chair to sit on right now. You wouldn't have your phones. You wouldn't have anything. You could argue that mining is the most important industry in the world, because without that, we don't have anything. Another thing is, which groups of people do we talk to? So I'll just show you a quick clip from our Sims movie.
Using the latest technological advancements. Did you know you use minerals every day? Without minerals, you wouldn't be able to clean your teeth, wash your clothes, or ride a bike. Cars, trains, planes, watches, jewelry, and food cans are all made of minerals. Even the internet couldn't exist if it wasn't for raw minerals. The European Commission's...
So in a couple weeks, we're going to take Sims to the International English School in Örebro. They have kids there in grades 4 to 9. And we're going to ask them about mining and what they think. And I think that last sentence is going to get them. Without mining, you wouldn't even have the internet. You know how kids are today. They're on their phones constantly. So we need to raise awareness for all different groups of people why mining is important. And that's it. Thank you.